Okay. Good evening, good afternoon, good morning, everyone. For our third session of the Open Mapping Guru and the Hot Tech and Data Team straight training series. So today we will be joined by our wonderful and very inspiring tech specialists, Omran and Nirab. But before we go to the juicy training part, let me just go ahead and provide some reminders. So this training is entitled AI Assisted Mapping in an Open Ethical Way. We will be running through 1 to 1.5 hours. So the point of these tech training series that we're developing is to connect remote mapping to field mapping and how the data is being used on the ground by first-hand responders, doctors, strategists, logisticians to deliver aid, to deliver support, especially in very important humanitarian settings. Next slide, Omran. So aside from that, there would be this is a part of 7 trainings by the Hot Tech and Data team. So we're in number 3 right now. So if you would want to register or get a calendar invite for the following other trainings, we will be sharing the registration link at the end. For those who are in this call, all trainings are recorded, and you may actually re-watch the training sessions via the wiki link that I shared. All recordings will be there, all resources will be there. Um, I guess that would be it from my end. I will be passing the floor to Omran. But before Omran, I hope you don't get weirded out that everyone is currently on mute because we're expecting an influx of participants. So just for the security of this call or this meeting or this webinar, we are putting everyone on mute. Please put your questions on the chat box, and I will be moderating the session with Omran later on. Thank you very much. Omran, please proceed.
Thank you, Miko, and thank you everyone for joining. You are more than welcome for this training. My name is Omran Najjar. I'm currently based in Berlin. I've been with HOT for around like 3 years. My background is software engineering and information systems. I have a master's degree in extreme learning machines from Turkey, and then I have another master in data analytics and information system management from Germany, Berlin also. Um, my journey started around like 2007, working on software development. And then in the first master I took in extreme learning machines is the one which brought me into the AI world. I've been also working with the humanitarian since 2014. Mostly this is because of my background and being from the Middle East and being around humanitarian organizations. And I landed then with humanitarian OpenStreetMap team working, focusing on AI for social good. And that's like where we're trying to use the technology and the emerging technology in order to accelerate the human impact out of the humanitarian actions. Since I can see in the current calendar in the slides that you've been watching what is the open drone imageries, how we get the satellite imageries, how we get the mapping, what are the editors. So somehow you know that we look at satellite imageries and then we do mapping. Initially, we select the buildings, and then if you know the roads, if you know further details, we also try to add that local knowledge. In the later stage, we will my colleagues will give you more details about how we collect those local knowledge. But so far, with the information you got until this step, until the third session of the training, like that step of seeing a satellite imagery and detecting that this is a feature, and from that feature detecting that this is a building or this is a road, and if you know more details that this is a tree or this is a water pond, this is a waterway, somehow seems to be obvious with the recent technology, and somehow some new emerging technology might help us. We're talking specifically about AI, and when we use the term AI here, we're totally focusing in computer vision models. I try to not use too much technical terms just to keep it like more open because of the wide audience and the different backgrounds. So somehow having an image and then detecting what's inside this image is something recent AI technology has achieved or approaching. Its quality is good, is not that quality. Sometimes it's accurate, sometimes it's not. But this is the problem we are trying to tackle. So and of course, humanitarian OpenStreetMap team have some core values like putting people first and working in the open. So we use those principles and those core values with the new technology, and we came with a new idea. We're calling it FAIR. The F is coming from like the FOSS, free and open source softwares. The AI is in the center, in the heart of our work so far. The R is coming from the tool resilience and our responsibility toward our communities. The communities, when we say communities, we're referring specifically to OSM communities in the global south in general, where HOT operates. We have what we call the 94 countries of operation, and then those are like in Latin America, Asia Pacific, and Northwest, Southeast Africa. Can you see the slides? I think slides are already visible here. Now, when we approach FAIR, we started with our why we proposed this tool, why we're working on it. We saw like so far 4 problems within the ecosystem of open mapping. The first one is lacking of AI openness, meaning the transparency of how AI works, the transparency of the models being open source. We believe that any new technology, especially when it's around AI, it needs to be open source because people need to see what's inside. And for a lot of people, the AI is being as a black box. What we're trying to do here is we want to take one step further and open that black box and see what's going on inside. Like going too deep, we'll need some data scientists and we'll need like mathematical background, physics background, but at least we want to bring the communities with us to have like a closer look and open that black box a little bit, shadow some light inside that black box, and then try to understand what's going on. That's why we believe in openness and transparency in seeing those models. Now, the second problem we saw is the biases in the models, meaning and somehow most of the data that's available around AI is coming from the global north. It's because of the development, because of the government's capacities, because it's the focus within all technologies. So somehow most of the models that are trained, they are focused on the global north. Somehow we're looking at leaning toward this global south in these scenarios and bringing data from the global south and the training using the global south data in order to mitigate these biases. I'm not saying we're going to be able to work without any biases. I don't think a data set without any biases does exist anywhere, but at least we're trying to mitigate it and have it less biased toward the global north and more balanced toward the global south. And this is where we have some localization idea. You will hear more about the localization soon. Then the third problem we have is the lack of a human in the loops, meaning whenever a model is created or an AI algorithm is trained, it's the algorithm itself, and that's it. People needs to use it or deal with it. Now, what we're trying to tackle here is we're bringing the human with us, we're bringing the end user with us, and let's do it together. Meaning there is always a human who is training the model. It's not the data scientist or the ML engineer or the AI engineers in the background or in the labs. We are bringing that into technical details to the end users. Plus, we're also including a human in the feedback loop, meaning when you work with an algorithm and you see something that's not good or less quality than expected, in order for in the traditional ways, a data scientist will need to know, and then they will tell the ML engineers work on some technical details in order to mitigate or overcome those challenges. There is no live feedback in the most of the algorithms within the ecosystem. Now, what we trying to solve here is let's have that feedback in a live environment. When you see the algorithm, you see what's going on, and if it's not that good quality, if you see something that's not good, give a live feedback, and you don't need to go back to the ML engineer or the data scientist to retrain or refine tune or recreate those models or enhance their accuracy. The last um, weakness or problem we saw is the lack of AI capacity. So that somehow aligns with the first idea of having that black box. If we go together, if you don't know about that black box content, let's go together and let's explore it together. Let's see what's inside. At one point, of course, there will be a need for different communities, different skill sets to go into further details. But at least as a first step, we are going together there, and then we are increasing that capacity by trainings, by including the human in the decisions, where to train, how to train, what techniques, what scenarios do you want to do those trainings. So far, fAIr is in the alpha stage. We are committed to have a release production mid this year, and we have already started expanding also all the models that we are using in current and fAIr. We're collaborating with Omdina AI, a collective um, we're running an AI challenge, a collective AI challenge, where around 50 AI ML engineers from across the globe will be joining an 8 to 12 weeks challenge, where we provide the data set. We have those data sets already coming from OpenArealMap. You saw OpenArealMap earlier and in the previous trainings. And we're also using OSM data, which is also open. And both of them will go into a pool of data sets. And then the 50 ML engineer will be working with us in order to tackle new problems, meaning when we started fAIr, there were no those big models that recently produced in 2023. So somehow we're trying to explore those new models, see what potential we can see and what we can integrate into fAIr in order to expand it. Within the current fAIr, we are limited to detecting buildings so far, but this is what we are trying to expand and looking at even having you, if any of you have any like technical capacity, technical expertise, I think we can share the link with Miko after with the slides after the call. You can join that challenge. It's gonna start in early April, in the 1st of April, so 15 days from now. Who are the end users who we're targeting in fAIr? We have a circle of users. We started so far with the hubs, what we call them, the open mapping hubs, and those are like humanitarian OpenStreetMap communities in the Asia Pacific, Latin America, and the Caribbean, Northwest and Southeast Africa. We started those training with those users, where we have two target users: the end user who is a mapper who will be using the model only, and then more of the community managers or more the activists on the ground who will be more interested in where is this data going, how we can make those projects run faster, and then how we can create the model. So it's one of the model creator, and the others more of the mappers, or we can call them even a model users. I will go into a little bit of further details. If you have any questions, put them in the chat. Miko will assemble them and we will be discussing them. I will go a little bit with further details of how we collect those training data sets, how we're training the models, and how you even can do it yourself. So in the previous trainings, mostly you have seen the open aerial map where anyone can contribute any aerial imagery. A nice story happened recently with the Northwest Africa. One of our collaborators there wanted to test fAIr, and he has a drone himself. So he went into the ground and then he ran his drone um, I don't know what they call it. I'm not an expert in drones. He owned the drone fly, and then he took the imagery. Then there is a software from Open Drone Kit, I think, and you can get that imagery and you can upload it directly into Open Area Map. Although the area was like a very small, because like running for big areas, you will need to get some license and then much more processing of the data. But that was like a very cool scenario we tried. So in fAIr, we use that imagery as it is. We're following the tile protocol. That's a little bit of geo information. It's exactly when you have a like the whole globe or the whole Earth, and then you zoom in and you zoom out. So when you zoom in, you see other images, and those are like different tiles. Those are what we call them as tiles. So we're using those imageries, and then within a very big, for example, area, you can define a small area, which is around 5 to 10% of the whole area, and then map it manually, meaning you can select small area and get the knowledge from that area, then train an AI model that will learn how to detect other buildings in the big area. Why we think it's working? Because the nature of the images in that area will be similar, because normally if you're flying a drone, the timing is the same, the colors are the same, they have the same nature. That's why we call this data set as a homogeneous data set, so it has the same nature. So big area, then 5 to 10% of that area you selected, and then after selecting it, you would be able to map it manually. And after mapping manually, we're anticipating around like 1 to 2 hours of manual mapping, like of a human efforts. They don't need to be like data scientists. Any mapper, anyone who conduct a training of 30 minutes would be able to do those trainings. Now, after doing that manual mapping for 1 hour, we are providing the cloud environment to do the training. It's coming also from HOT, from Humanitarian OpenStreetMap team. Now, the training with our experience so far has been done between 10 to 20 minutes to a couple hours. The longest training has took around 24 hours, but that was like a very big training data set. It took around like 7 to 8 hours to map it. And then the training took 24 hours after that. So somehow we're saying within 24 to 48 hours, you would be able to create your own data set, train your own model, and check its accuracy. Now, that's like you creating your own chat GPT within 24 hours. That's similar scenario, but it's your own chat GPT. It's your own model, your own algorithm. It's open and accessible by everyone. And you can even see the details below it. See the different tactics, um, different variation that happened during that training. Now, after you create that model, you would be the model creator, but then you can bring other mappers with you. And as the picture in front of you or the one on the right side, within one click, you would be able to see where are those buildings. You would be able to get all of those predictions, we call them predictions, and deploy those models. Now, after getting those mapping or predictions with one click for each one of them, you would be able to take them and push them into OSM. And or you can download this data and use it in a different places. Now, this is where the human is in the loop. So the mappers will come here. And this is a very cool example we're showing in the screen, but if it's not that good, you can submit it as a feedback. So rather than pushing, or you will get the prediction in front of you, then it's even use accepted, and that's a good data, or you will send it back to the model creator. The model creator then will get those and will make their own decision. We will come soon to this one. But the first scenario is you accepted this data and you take it directly into OSM. However, so far, fAIr will be in the end-to-end scenario. I think someone told you in the previous calls about the end-to-end scenario where someone will grab the imagery from the ground, then upload it to OAM. Then you've seen in the previous call, tasking manager, how we divide the areas into smaller tasks, and then everyone is assigned to his own task or their own tasks, and then map into OSM. We see fAIr exactly after that step. So you have assigned this task, then the assisted mapping tool will help you to map it much more quickly. And from there, it will go into FMTM, which is like the field mapping tasking manager. This is where we get much more data, much more local knowledge. And that local knowledge is more of, um, if this is a school, or further details about the shop, the phone number of that shop, the phone number of that hospital, and you add more details into the map. Those are much helpful for stakeholders, for planning, for governments, and also for actors on the ground. Uh, this is very okay. And my next idea is, how did we arrive here, and how did we reach this place where we are in fAIr? It might be a complex image in front of you, but each part of it reminds me with an activity we've done. On the top right is when we did a an Omdina challenge, similar to the one we're running now, but it was the initial one. We did it in November 2022, the end of 2022, between November and December 2022. Also 50 engineers joined the challenge. We didn't have the same amount of training data set. We had like much less training data sets. We didn't know the details of the geo information that we'll be extracting, but there is where we tested multiple models. If you have heard about the Open City Challenge, they were like in 2019, an Open City Challenge challenge, and then one model has got the award among that challenge. It was about detecting buildings from satellite imagery. We tested that model. We tested different other models that were proposed by the team, and we tested another model called RAMP. And RAMP is the one you will see on the slides on the almost the bottom of the screen. So the RAMP is a replicable micro planning model that is developed by Dev Global, which is another humanitarian organization, but we participated and we contributed to that model to that project as technical advisors. And the model was totally open source. It showed a very good accuracy, and it is the current model that is adopted in fAIr. It's the only model adapted in fAIr so far. We're looking at expanding this with the new AI challenge that will be starting soon in April. And from April, hopefully in the next training next year, you will come back here, and then you will hear that we have other models. The researcher knowledge in the middle is called Christopher. He's now a friend. He was once a volunteer with HOT. He's still a volunteer. He's a master student. He joined our Slack. I think you're all already in our Humanitarian Maps team Slack. He sent a message saying, I'm doing a master in remote sensing in Maximilian Institute in Germany in collaboration with DLR, the German Aerospace Center. And he was looking for a challenge in order to use it for his master thesis. What we did there is we provided the training data set and we got the results. It's that research where we got the localization idea. And by localization idea, we're saying, rather than having a very big model, rather than having a big ChatGPT, let's have a very small model that is focused on this smaller area. And as long as you as a community member, you as a local mapper can create it, we don't even need data scientists. You don't even need ML engineers. You don't need that experience to do it. You will be able to do it yourself. This is where the localization idea is coming from. And the results from Christopher's research was the one which gave us the hint, the trigger that this might be a good transaction, a good direction. It's in the next trend, and we went through that. The next picture on the right side, left side below is the humanitarians and researchers. That was an AI for social good seminar in Germany and the border between Germany and France in a castle called Dachstuhl. It's a castle that you can rent for a week. They have the room, they provide the logistics, they provide the library, and they have the presentation halls. And there they bring humanitarians, they bring data scientists, they bring researchers. We sat all together and we brought our problems. Um, and out of that problems, we did a hackathon where some of the two of the data scientists there, they created a model within couple hours based on my own mapping, my 1 hour mapping, and that model performed very well in that session. This is also another proof that we got into supporting fAIr idea and taking into it. NetHub is an AI working group. It's an alliance between multiple NGOs. We are part of that, and then we get a lot of ideas from there. We collaborate with other NGOs, and we get more insights about the direction and where we want to go. Um, where's the mouse? Here we go. Um, I thought of having more details about the infrastructure of fAIr, but that's like a little bit technical. I won't go into like too much details about it, but what I message I want to deliver is somehow we're working on modularization. So we have one section that does something, another section that does other things. You, as a collaborator, you're more than welcome to get involved, get more details. You can pick up one of those areas and collaborate one of those modules, contribute to it based on your expertise. If you have a background in Python and writing backend code, we have that section. If you're more into an AI engineer and the technical skills working on TensorFlow, on PyTorch, you're more than welcome to go in that area. Front end design are totally different places. So we have those like fAIr architecture where you can contribute to different areas. Um, that's the general workflow we have on fAIr, where we have the satellite imagery, we grab OSM data, we build those model, we localize the model, we do the training, we get the feedback, and then we do like iterations of training. We get the feedback, we retrain the model. It's good, it's perfect. It's not good, let's retrain, give me some feedback, and let's leave that infinite loop until we achieve our goal. Um, where are we going in the coming future, in the coming near future? Currently in fAIr, we're supporting only binary segmentation, which is just detecting if this is a building or not a building. If you can see on the left bottom side, these are all somehow buildings, but they have different nature. If you see those like almost rectangles, smaller ones, those are tents. If you zoom in into that image, you will see the UNHCR logo, and those the UNHCR tents. And compare with the buildings beside them, they have like different rooftops. So we think that models should be able to detect those different features and even name them. So far, we are detecting them as they are all the same, but we are looking in the current challenge, in the coming challenge in next month, to have different type of features detected. The right side, that's also the ultimate feature we're looking for, is using the street level imagery to detect more information, more local information. Because when we have street imageries, there were someone there who had their cameras and they were walking there and taking picture or driving their cars. Google car won't go there, by the way. But when someone is taking those pictures, um, we respect those privacies, but also we can get some information from those images. You can get a phone number of that shop. You can get if there is a blocked road or not. If there are electric poles, if the road material, you can expect to find it from those satellite imageries, if it's paved or not. Those are like the next level features that we are looking at using AI to get them. License wise, we work in the open. That's like a core value in Humanitarian OpenStreetMap team and in OpenStreetMap project. Everything is open for us. We're using the attribution, the common Creative Commons for so far. You can see the license in our projects in GitHub, and you're more than welcome to be involved. How can you get involved in fAIr into those starting scenarios? If we have enough time, I think I can share my screen and show even some live demo from fAIr, where you can, as a mapper, see the model and see how it's created, and even use the prediction directly, or create your own model directly. The tool is still in the alpha version, so somehow it's not open to everyone. We're not sharing it. Actually, it's open, but we're not sharing it outside so far because we're focused on testing. You're more than welcome to test, of course, and if we have more time after the questions and discussions, we will go into a demo. This is me on the left side. Kshitij is the main developer who's also working with me. I'm not sure if he's in the call here. He's based in Nepal. And this is our GitHub repository, the current one. If you have your phone, open your camera, scan the code, you will go to GitHub. If you have your account, give us a star there, and let's start to contribute. Um, did I take a lot of time? I think we're okay with time. We'll get it back to you, Miko. If any questions can be assembled, any discussion can be starting. If anyone would like to unmute.
Okay, thank you, Omran. So I think Nirav was able to answer the question that Pawan shared. So I'll be throwing to you the question that Ralph shared. So his question is, as we know, each new release of satellite imagery, the position and alignment has changed. How does the AI predictions handle the changes in imagery? And does it adjust its existing predictions or does it create a completely new prediction?
Thank you. Very deep question, Ralph. So far, that's more of a conflation problem rather than an AI problem. The new imagery that's available will have a little bit of different nature. So somehow we would be able to create a new model on that imagery and train it on the new imagery, and would be able to detect it. Now, if there is a little bit of shift, somehow if it's like a standard shifting, we can move the whole features all together to match. But if it's a little bit changing, more like changing, that would be more of a conflation problem. So we would need to check which feature is better, what's the history of each feature, do we want to keep that history or not? Do we have also more local knowledge that is associated with that feature so we can move it to the new? Are we in the conflation changing the geometries only, or are we also changing much more of the history of the and the tags of those features? Um, Hopefully I answered that question, Ralph. Thank you.
Thank you,
You just
Amran.
come up.
Another question from Lakshya. How well would it be able to perform on low resolution satellite imagery?
Good question. Thank you, Jalal. Uh, all the imagery we have tested so far are between 5 to 15 centimeters. We tested, and Nirab is the one actually who was testing a lower quality imagery. I would say it's much more challenging, but it's not impossible. Um, Currently in FAIR, we are just using the open source imageries from Open Aerial Map, but we're also trying to seek other satellite imageries from other techs. And I will give you the floor, Nirab, here, since you know the area. Go ahead.
Yeah. So I think better the quality of imagery, better your predictions. But I think we got quite a good results with uh, 30 meter. I think those were like
That's
30
meters.
meters or 10 meters like resolution imagery. So if you have that imagery, you still can run predictions, but like it won't be as good as the ones that Omran showed you. Like it probably they were like 4 centimeters or 10 centimeter resolution, so it won't be as good, but still you'll be able to get something from them.
I want to also highlight here that somehow it's the community who is deciding the accepted quality, meaning in case of a disaster, um, as a humanitarian respondent, I will be okay if a building is not that accurate, but it's there. I would be okay if a building is intersecting with a line which is like a street, but as long as it exists. And compare, and that's like in a disaster response area and scenario. But if it's like more of a development scenario where the municipality or like local or NGO want to do some urban planning, I would need much more higher quality data before I make my decision. So somehow we're keeping that like the level of the quality more into the community decision rather than it should be always get perfect.
Okay. So far, there's no more questions. Ran, you mentioned that you can possibly do a demo, a bit of a
Yeah.
demo. Would that be? Would
Do you
that?
see?
Yeah. Yes.
I
Would
think
24?
everyone can see.
Yeah. Good. 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 Yes. Thank
Cool.
you.
So this is fair. Um, the learn section is where you have the details of the steps that you can follow in order to get all the full scenario from getting the imagery and then until creating the model. The training data sets is where it's your start. And so far we have like 192 testing data sets that we have created from different users. This is Nirab. He's with us in the call already here. I will show you one cool model that we worked on. It's like from Kakuma. I think that's Shitish ones here. So this is in Kakuma in Kenya, where we have a satellite imagery for refugees camp. And what we did is we created this small area here, and this is somehow like 10 to 15% of the whole imagery. And then we mapped this manually. It was already mapped in OSM, to be honest. We didn't even need to map it because we ran the project even before having fAIr. So the areas is already mapped. So we're detecting that those are buildings, those are buildings, those are buildings. And we decided to have two areas just to be more representative. This is an idea I forgot to mention also in the previous presentation. The more the training data set is representative for the area, the better quality you're getting. The bigger the data set is, and the more representative, the better quality you're getting for the model. But of course, we need to find a balance at the end. It's more of the community decision or the one who's creating the model decision. Where do you want to stop? You want to keep mapping for 15 hours? It will be exhausting for you, but it's also you're gonna get a very good accuracy. So we need to find that balance, and we're keeping it dynamic. So the community is deciding when to stop. So for this small area, we have created one model. Shitish has created his own model here. And the model training sometimes took 15 minutes. Then for a bigger data set, so he had a previously smaller data set of around 80 images, took 17 minutes. But then after that, around an hour when the data set was a little bit bigger of 400 images. Um, I would like to explain here what's the epochs and patch size. Those more of like technical data science terms, ML engineers terms, but we kept them here because we understand them as the one who created fAIr. But now we're looking at more making this more of like end user friendly rather than like this. So 20 epochs and 8 patch size. Imagine that the algorithm is a child, like an 8 years old child at school. Then you wanna teach that child a new book. That book is the data set. The model, the AI model, is the child, and the data set is the book. So you will give that book to the child and tell them to read it. If they read it once, that's one epoch. If they read that book 20 times, that's 20 epochs. Now, when they read that book for the first time, they will have 8 pages and read 8 pages. Then next 8 pages, next 8 pages. This is the batch size. This is exactly how the algorithm is learning. We're dividing that data set into 8 pages, 8 images. We're feeding it into the model. This is one. Then the next 8 pages, the next 8 pages. When we finish the whole data set, this is one epoch. So we're making the model reading the book 20 times in order to learn and understand. And those 20 times are all documented. So you will see those 20 times here, and then you will see how the accuracy is changing over time, over each read of the book. Normally, and the standard is the more you read is the more you remember or the more you become smarter. And in this scenario, it's not always like this. Sometimes it goes up and then it goes down. This is where we call it an overfitting. If you have heard about what's overfitting in AI training, that's the overfitting. It goes down after it reached the full knowledge. Similar to random forest model, I would say yes, but this is our UNet with efficient net model so far. We'll take you now into like a live scenario for mapping where you can define whatever area. We have different parameters here that you can tackle, and then running a prediction. This click of running a prediction now is similar like sending a message to ChatGPT. You send a message and then you wait for a second or two, and then you get a response. Because we're using here like a very minimal specs, the training, the response is taking 10 to 15 seconds. The maximum has taken is around like 15 to 20 seconds. And those are the new predictions we got so far. We have like different configurations. If we change this configuration a little bit, we might be able to detect like even those smaller buildings in between. I'm running a prediction again. Hopefully we will get good results out of it here. It's 14 seconds. We got somehow much more complete. For each feature, you can decide it's even you accept it or you send it as a feedback. Go to a different place, like to take those back into even Miko, you're surprised I didn't show you this, Miko. Sorry, man. Nirab knows it and I has seen those before. Setting those features, you can take them directly into OSM. We take them to one of the editors, and from there it's more of the editor scenario or the editor's standard procedure, how you can do it. Go to a different place. Let's try those different type of buildings. That's similar to the one I used in the presentation, so mostly it will work fine. Because I got that like a GIF from this same data set. Okay. That's okay. Although I don't see this as a building, but I can ignore it. There are like some artifacts coming here. We can ignore them. So I can decide what's the quality I need, which features I need to use and send them into OSM. The feedback is something important. Since I submitted now those feedbacks, I would be able to come back here and see those bad feedbacks. So someone sent me a feedback here saying the model is not performing well here, and it's not performing well here. So this is where me, as the one who created the model, I saw the mapper's feedback, and then I will come back and make my decision here. Based on their feedback, I want to retrain in this area, have a bigger training data set, put more efforts into the data set quality, and that should give me back a better model and a better accuracy. Again, going back to that loop, and then that loop until we finish the project, we finish the mapping in that area, and we reach our goal. 144, and back to you, Miko. Any questions?
Yeah, I think we have a question from Arnold. So, in the past, I saw that to use this tool to generate features with AI in a region, it should be a project completely mapped in the same region.
Y- Now, if it is mapped already, like, we used it in a region that is already mapped to prove that it works. Uh, Currently, we are running projects. The area is not mapped, and we have the imagery, and we want to map it with the tool. Again, fAIr is still in alpha version. It's not like into production. The infrastructure is very small. If you saw noticed here in the link, it's called fAIr Dev. It's not like the full fAIr yet. This is a minimal specs environment. This costs us only $300 on the cloud environment. Like this is even cheaper than your laptop, like a personal laptop, someone's laptop. It's not like a production release. Um, if the important scenarios, Arnold, it's more of uh, having the data, having the imagery, do the mapping. If it's mapped already, that's even easier. But if it's not mapped, we need the 1 or 2 hours of efforts to do the mapping, then create the model. After that, the conflation is another problem. Do you want to replace what's already in OSM, what's already mapped, because your prediction are better? If they are not better, you want to merge those two um, and take it into the next. Go ahead, Neil.
Yeah, so I think in terms of utility, like it would make your life much more easier if you are mapping, like, some place where there hasn't been much, mapping, because later, like when you use that data and then try to map in OpenStreetMap, you don't have to worry too much about, like the conflation stuff, right? What is already in OSM versus like how my predictions that I ran through fAIr, like overlaps, or is it, like something, how do I deal with existing data already in OSM? So it would make much more easier for you to, like, map a blank area. But
Mm.
there's hardly, like, any area in OSM that is, like, completely blank. So from a project management perspective, like it would be like, you get this imagery, you define a small area, a percentage of area, 5% or 10%, where you train that data set, where, like you make sure everything is mapped properly and correctly. And then after that, like you run the model based on the training area that you have defined. Oh, okay, this is the correct mapping. And from that, what fAIr does is gives you prediction for other remaining area. So other remaining area, like fAIr guesses for you, like, oh, okay, this is the building based on what you said for me in the training data set. This I think is a building. And now you can take that data, and then you can create that mapping campaign for yourself, so that, like it simplifies your mapping effort. So that's the whole idea of fAIR. So it does not have to be exclusively, like, something that is already mapped, or something that is not mapped. But you'll probably need to, like, map the area that you want to train, like, properly. So you have to map that area properly.
Recognizing your question, Jalal, about cleaning the points and rough edges of the buildings. Somehow, yeah, when a building is somehow having a tree on the corner, the colors is are not detected as buildings. This is because the models are working on raster images, meaning the AI models, they understand pixels. They don't understand the geometries so far, at least from for the models we have seen so far. So we have what we call a post-processing step, which is after we get the tile, we get the image, we are converting this image from being pixels into a geometries. Now, this process is a little bit challenging. Jalal, if you have that experience, you're more than welcome to contribute. Like, come to our repository, send us an issue, and then we can talk into further details if you can support in that area, in that post-processing step of how we take those pixels into geospatial data, how we have a perfect squared building. If it's a squared, how we have the edges as 90 degree. out of those multiple points we have, that would be amazing. Like that would be a valuable contribution. One good thing during discussing with our tech team is detecting round buildings. Somewhere in Africa, there are like some hoots. I don't know what they call them specifically. If Nirab, you know those things, can you type it in the chat? Some buildings are rounded, so they are like circles, and then most of the detections, most of the models, they will see them as squares. Huts, exactly. So those are somehow circles. What we've achieved here also in fact, it can be detected as huts, exactly. It can be detected as huts, but it will have a lot of points. It won't be a perfect square. I don't think we can have a geometry perfect square because at the end there will be dots at the end. Like a square with zero angle is almost impossible. Next question.
Any more questions from the participants? Okay, we have another one from Ralph. Hi, Ralph. How do we introduce AI to instances where the roof image is not the same as the footprint at ground level, as in the case of the top of an office block that is a part of a bigger shopping mall below?
I think with the representative data set, um, Ralph, so the more examples you have around those roof images, the more you feed the model about them, the more likely to be able to predict them. When we started detecting buildings, our director asked me, like, when are we going to start predicting schools? And from satellite imagery, when are we going to start predicting schools? I told her, like, when you give me more schools and how they look, I can tell you how we can predict more schools. So somehow it's more of how much the data are representative and how the data set is representative, the model would be able to learn. That's similar to the child when we gave them that book. So if they know what is a school, they would be able to predict what is the new school, how a new school would look like. But majority of the data we have are more about buildings, although we are trying to see from the colors if we can detect those like different classes. We're calling so far them classes, but it's going to be, for example, rooftop material, if it's like metal or different things. Go ahead, Niro.
Yeah, it also brings me to, like, one thing that I really love about, like, here is, instead of, like, one particular AI model being run, through a global data set, what we can do is, like, we can actually, like, take a very local sample of aerial imagery, and then in that local area, like, so for example, if I'm doing mapping in Kathmandu, then, like, there are houses in the hills of Kathmandu. So there are, like, houses in where there is, like, very core city area where, like, buildings are very tightly together with each other, and then there are, like, little bit on outskirts where there is, like, more apart from each other. So based on, like, what kind of prediction you need, like, you can accordingly train your model, and then after you have that thing, like, you have a very localized, like, model that can give you very localized predictions. So that is something I really love about here as well. And then I think, like, in the case of, like, the question that Ralph is asking, like, so having that training, like, very localized training, would be, like, the answer to getting those localized predictions.
For your question, Philippe, about the tropics and partial roof covered, um, it works very well, actually. I was not expecting this. Even for roof, which is like very shaded, like different colors, it's still detected as one building. As long as we have more representative data in the training data set, I've seen some example, which I can maybe refer to you after the call, um, where we have those shaded buildings, shaded rooftops, but they are still predicted as one building. Um, uh, I would expect that it might be detected as different buildings, and then you're expecting that if a building has the same roof color, it will be one building. But even if it's shaded, we were able to predict it. Again, it's about how representative the data is. I've seen those examples, and an example I have also, I think from same as your region, we had an example from Acapulco where there were already, the imagery has already damaged building. That was, I think, a hurricane. I'm not sure. It was even a hurricane or a flood. The damaged building is mapped as one building, but what's inside that building from the image is totally chaos. It's like damaged. You could see even like a cabinet that's like on the ground of the building, different colors. It's not one nature of color for the building. Still, we were able to predict those and compare it and like differentiate it at least from the background or the road colors or the water around it, because it was even, I think, a hurricane or flood. I can give more details about those, Philips, for the hubs, also for the whole hub.
Yeah, thank you, Amran. Another question from Judith. There was a mention of detection based on pixels. Other than complexity in detecting the circular buildings, is it possible to map the complex buildings such as ones with sharp edges and not the regular outline?
Yep. There is a very high potential. If you see it in our example here in my screen, those are not even, they are sharper edges because those tents are more of tents. They don't have like a square style. Even the circular ones will have much more point. This is why we have those vectorization configuration. I didn't go into like too much technical detail, but looks like those questions are taking us there. So the area and the tolerance are the configuration, the vectorization config. This is what we use when we get the raster, and then after the raster, we want to transfer that raster into a geospatial. The area is, we are ignoring the feature, the detected feature, if it's less than 1 square meter, meaning we introduced this feature because we were predicting cars as buildings, because the buildings were white in one of our scenarios, and then the cars were white. So the model was predicting the car as a building. So we wanted to have this threshold of having it. And then we didn't want to have it as a fixed threshold. So we had it as a parameter. So you decide if in this area you see small things are not buildings, just have a higher threshold. In this scenario, I would make it like a smaller because it's not predicting things outside. So somehow for me, 1 square meter is good in this scenario. The tolerance is being the the distance between points. When we have a polygon, the distance between points in meter. So if it's a 0.3, we're saying approximately between each point and the next point, we have 30 centimeters on the ground based on the quality of the image. So that's what you can change. Like if you have a tolerance higher, it will be even harder to detect circular building. If you have hoods like the examples in Africa, it's much more recommended to have less tolerance, like 0.3. We had it as a default, and then from there you would be able to detect those circular building. This is where like the human is making that decision. We don't have a standard. We have recommendations, but we don't have have it as a standard. We recommend the 4 square meter area and then 0.3 tolerance as a default values, but beyond that, it's you who is designing, the mapper who is deciding what configurations are much better and how I'm getting the best quality.
Thank you, Amran. Another question, Ralph, from Ralph. Have you introduced fAIr to the typical roof shapes that exists, such as flat roof, gable, hip, etc.?
Unfortunately, Ralph, we didn't start this yet, but that's the potential of the coming challenge in April. Although we don't have a lot of training data set to provide to the collaborators there, we don't know if you know areas where open aerial imagery is used, then we can use the imagery and it has a lot of roof shapes. Please let us know, send us the locations, and we will be able to create that training dataset and append also what we have already shared for the AI challenge. But that's the next challenge, Ralph. Hopefully, we will tackle it together.
Okay, any more questions from our guests, participants in the call? Omran, any final words for our training today?
Um, you're more than welcome, everyone, to collaborate, contribute. I will share again the barcode here so you can scan the code and see it. I don't know what happened. This one. Okay, now you should be able to see the barcode. Scan it. If you see an issue, raise an issue. If you would like to contribute, you're more than welcome. Depends on your expertise. Just get in touch with us. You're more than welcome. And thank you for attending. Like, it's hilarious to see around like 90 people joining a call and volunteering, learning something new and contributing. Thank you, everyone.
Thank you so much, Omran. So before we wrap up this call, please, a reminder for everyone, please do answer this e-certif, the participant form. Omran, we have one more question or few. Rosemary, what is the most appropriate way to get potholes, hanging branches, dangerous things?
Um, that's like a hard question. Um, but satellite imagery, maybe. I mean, like street level imageries, maybe could help there, but they are not available also. And I don't know any model that is like specifically working about potholes actually. I would, yeah, go ahead. I don't know. Like, can you unmute Rose, please, Nico?
Give me 1 second. Okay, Rosemary, can you try unmuting?
Hi, good morning.
Good
I
morning.
want to be able to, I am planning to use the open street and hot to work on preparing areas where blind people and people with disabilities can traverse. So I would want to know what would be the best way, because I want the area that I'm planning to do. I walked it. So I realized there are hanging branches that might be dangerous, potholes, open trenches, and those things. I want to know how would be the best way to get those on the map, because I might not be able to. I'm from Jamaica, by the way. I might not be able to do all of that.
Um, I cannot give you an off-the-shelf solution, but I can recommend couple algorithm for that. I've seen some of them called YOLO. It's like you look only once. It's not like you live only once. You look only once. And currently the version
Okay.
is called YOLO version 8 model. So far, that's like a very light model. So somehow, if someone with a disability, they cannot see their way, and they have, for example, a camera, and then using that algorithm, because it's very light, it might give some sound notifications saying something is hanging in front of you, so you might be hitting something. So somehow I can support you with the algorithms and themselves. I don't know how that can be implemented, but you're more than welcome to get in touch. Like I'm very interested actually in the idea and how we can contribute to it voluntarily as a tech team. I would love to hear more about that problem, see how we can support and like give advice, collaborate, contribute, and hopefully find a solution for you. At least like define what direction you can we can support in which direction you can go.
Okay. All right. Thanks. What do I do? Leave my email address?
Leave your email address or get in touch with us. Here are our emails on the screens also. Mine and Chitter's.
Oh, okay.
Thank you,
Perfect.
Rose. So,
Thank you, Rose.
You're
for
welcome.
everyone, for everyone who would want to also get the e-certificate, please do answer the participant form. It's already shared in the chat. Yeah, and you may contact Omran and Shatij, and the QR code also is available on the screen. So before we go, I would really love for you to give me 5 minutes to do some announcements. But before we go, Omran, kindly get Rose's wonderful email. The best way that we could learn from these trainings is really to appreciate the trainer and give feedback. So I'm sharing to you for everyone to put the feedback to answer the feedback form I'm sharing right now. So please provide feedback to Omran for this training so that or even leave a message. Omran, thank you very much for this opportunity. And I would like to share my screen for a couple of minutes. Give me a sec. Uh, Omran, can I share my screen? I'll
Yep.
close. Okay. It's not this. Share again. Start presenting. Here we go. So some few announcements from the Open Mapping Hub Asia Pacific. So today is the deadline for our data camp donates campaign via the Humanitarian OpenStreetMap. So if you're interested in getting a premium access for DataCamp, so if anyone knows DataCamp is an online learning platform, if you want to learn more about data science, analytics, etc., please do register in this QR code. And we are giving away premium DataCamp accounts for humanitarian mappers, contributors to the open mapping movement, etc. So here's the QR code. I'll just leave it for a few seconds. Uh, and also you can visit the Hot OSM Facebook page, LinkedIn page, Twitter. The link is also there if you are interested. So today is the deadline. So I hope everyone who's interested, don't miss this opportunity. We still have 4 different tech training topics, so feel free to scan. For those asking for the recordings, it's not instant, so feel free to visit the wiki page we shared. The presentation is already available there, but the recording might take an hour or two before I upload it. If you're there already, feel free to also register for the other trainings. We'll be sending you the meeting link. So we have open field mapping tools with our very own open mapping guru Faye Andal and Susmina Manandar from NAPSA. We are going to have a training topic on accessing and visualizing map data, open map data, and some sessions with John Bryan from Mammoth Geospatial for QGIS. So please do not miss out this wonderful training. So as you can see here, it's an end-to-end training session wherein we started with drones, we moved with mapping, remote mapping tools. Right now, we are working with AI. So for the following topics, we're working with mobile collection tools for next week, and then access and visualizing web maps, etc. For the 5th session, and then more technical QGIS stuff by the 6th and 7th. We also have some deep dive training sessions. So as you may have noticed, Omran just showed you like a tip of an iceberg type of presentation, a demonstration. But we will be having some deep dive hands-on training sessions. Like for tomorrow, we have UMap. It's an underrated open platform wherein you could visualize your geospatial data and of course OpenStreetMap data. Feel free to register as well in the link. And we have Ushahidi for the 29th of March. So all these trainings, it's in the registration link. Please, 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 please do register if you're interested so that we could send you the calendar invite. For those who are looking for a challenge or wanting to support or help open mapping, we are actually updating 3 island nations in the Pacific Islands. So this is Vanuatu, completely updating Vanuatu, completely updating Tonga, and completely updating Micronesia. So these big 3 countries, were updating the whole data set, buildings and roads for all these climate susceptible countries. so that they have that access to that data set. So please access these projects and the hot tasking manager. Map a few. We are all for incremental help, incremental support, any help and any support from the mappers, validators. Please do jump in. Yeah. And if you are working for a civil service organization, an NGO or academia, and you want to start your open mapping journey with your team, please do reach out to us. We can support you by providing a free one to 1.5 hour training with our open mapping gurus from all over the region. So feel free to reach out to us at the Open Mapping Asia Pacific Hub and Open Mapping Hub Asia Pacific. So yeah, and we'll be more than happy to coordinate when, where, what, when, or how we could make this work. Lastly, you could reach out to Hot OSM team via the Slack channel. Please feel free to send an invite to our Slack channel so that we can add you to the group. And then lastly, I'm going to add here Lean's email and the AP Hub's email so that if you need to contact us or reach out to us or inquire about anything, you do have that access. So thank you very much for everyone who has joined us today. We will see each other next week, same place, same time. Oh no, it's Saturday next week. So next week it will be a Saturday session. I'm going to stop the recording now and have a great evening, everyone. Any more questions?